Here at New Way Air Bearings, we're studying conductance systems for vacuum in the conveyance of glass, using our air bars for conveying the glass in a larger system. You see here a blower which has its output ducted outside of the box. It is connected via PVC tubing to a junction, and one side of the junction goes to a facsimile of 32 conveyors. So you'll see that this is a plate with many holes, 412 holes in the plate. This is also attached to a valve that can be used as a breather valve for the system, and we also have an aperture that is used as a method for controlling the pressure as the glass goes on and off of the system. The other side of the junction goes to a smaller tube which is feeding only one conveyor, where you will see that we have about a meter's worth of holes attached, and in this experiment we have the exact same foot as the customer is using in their assembly. This is a drawing of the foot that is under test. Here you see the mounting component, and here is the vacuum hole. So we're wondering if this is too much restriction. So we've set up the single test on the conveyor to determine if that is a significant restriction or not. We have two manometers that we're using to test pressures. And you can see 1, 2 manometers. One of the manometers is feeding into the end that's next to the hole that we are testing. The other manometer is fed into the opposite end of the conveyor, so that we can see if there's any pressure drop along the length of the conveyor. At the end of the conveyor where we are drawing the vacuum, you can see that we are checking it right in the end of the end cap, as we are on the other end, but we are also checking it in the manifold that's on the opposite side of the hole that we are testing. That way we can test if there's a restriction made by the hole by testing directly in this manifold, which is on one side of the hole, and in the plenum of the conveyor, which is on the opposite side of the hole. We also have a manometer attachment in the plenum of the replication that we have of the 32 1-meter conveyors. That is the 412 holes that are exactly the same length and size as the holes in our conveyors. So this is a replica of a much bigger conveyor system. The blue tape is covering 1 meter's conveyor's worth of holes, which is made up from this conveyor here. So this conveyor's holes and the holes in this plate are equal to the holes in the total system. We are about to turn on the blower and check for the pressures, which have been adjusted to about 1 to 2 inches of water pressure. Here you can see the manometer is showing 0 pressure differential. Jim, go ahead and turn on the blower. So that's about 1 inch of total water. That's the pressure that is in this plenum. We have the relief valve turned off, but the system's relieving itself through this relief door. Okay, 1 inch of water pressure on that manometer. We'll have a look at this one. You see also about 1 inch of water pressure on this manometer. Then let's go ahead and switch to the other side of the hole where we're wondering about the conductance. Okay, go back. Again, you see about 1 inch of water pressure. Okay, let's go to the far end of the conveyor. Okay. And here we've got about 1 inch of water pressure again, even on the opposite end of the conveyor. Okay, with the draw through this plate and the draw through this pressure damper, we've got about 1 inch of water pressure. Now Jim, let's cover the holes to replicate covering the system with glass. Okay, so the water pressure is increased to about 2 inches of water pressure. Jim, go ahead and take that paper off. There you see it goes back to about 1 inch of water pressure. Go ahead and put it back on. Back to 2 inches of water pressure. Okay. Now Jim, just show me what happens when you cover the end of this pipe here. Just going to put a piece of cardboard over the end of the pipe. No, leave it like there's glass on it. Have a look at, whoa, see, we pegged the manometer. Right? So this is what happens if you don't have some sort of relief in the system. You'll build up an incredible amount of pressure, basically deadheading the blower. Okay, so with 2 inches of water and the array covered with glass, the pressure adjusting door is wide open. Now an alternative method would be to open the valve and cover the door. So now we have the blower is able to breathe through this valve. The array is covered with glass, and at this point we have about 4 inches of water pressure. Now take the glass off, and we're down to almost 2 inches of water pressure. Put the glass on, and we're back to about 4 inches of water pressure. So this would be another way of minimizing the pressure increase as the glass covers and uncovers the array. This is basically a vent with a valve allowing you to adjust the amount of relief that you're giving to the pump. This is another method here where the vacuum force itself is used to open and close a door that controls the pressure in the plenum. We believe that this system is superior and will forward to you yet an improved version of this pressure regulating door.